the last lesson, we explored what ratios are and how they describe relationships between quantities. In this lesson, we are going to focus on solving ratio and proportion problems. That means we will use a known relationship to find an unknown amount. One helpful way to do this is with a strip diagram. Let's suppose we have a ratio A to B. The first step, we draw A squares in the first row. We then draw B squares in the second row. From there, we can figure out what we know, find the size of each square, and go from there. Let's suppose that we have a ratio of blue paint to yellow paint, that is 2 to 3. So the first row, the blue row, gets 2 squares. The second row, the yellow row, gets 3 squares. This picture tells us that for every 2 parts blue, there are 3 parts of yellow. Now here's the big question to ask when solving. What do we know? Do we know how many are in the first row? Do we know how many are in the second row? Do we know the total? Once we know that, we can determine the size of each individual square. That is the key step. Each square represents one equal-sized part. Then we use the value of one square to find what we need. To summarize, we draw the rows based on the ratio, decide what the rows represent, identify what's given, find the value of one square, and use this to find the answer. Let's suppose we knew that we had 10 gallons of blue paint. Since there are 2 sections in blue, we would divide 10 by 2 to get 5. So that tells me that each of these squares is worth 5, and that'll be true for all of my squares. So the yellow parts, the yellow paint, we have 3 squares that are 5 each, so that would be 15 gallons. If we wanted the total amount of paint, well, there are 5 total squares, and they are each 5, so we would have 25 gallons. Notice we don't need to memorize formulas. We use the structure of the ratio. As future teachers, this is important. Many students can set up proportions mechanically, but may not understand why the numbers go where they go. Strip diagrams help students see the relationship. There are 3 common types of ratio problems we will solve. First, we might know how much one part of the ratio is and look for the total amount. Second, we might know how much one part of the ratio is and we're looking for how much the other part is needed. Third, we might know the total amount and look for one or both parts of the ratio. We will practice all 3. The main idea is this. A ratio tells us how many equal-sized parts belong to each quantity. Once we know the size of one part, we can solve the problem. You are doing great. Ratio problems become much more manageable when we slow down and ask, what does one part represent?